Welcome to electronics SLR. In this section, we will see one long question. So, previous lecture we will say discuss one long question. The second long question is that there are divided two parts. So, write in short note between the properties of continuous time Fourier transform. Okay, this is 8 marks, and second 8 mark is there is a difference equation. Okay, so this is our 8 marks. Okay, that we will see properties of continuous time Fourier transform. Okay. So first property is your linearity property. Okay, so linearity property says that if means if x1 of t the Fourier transform is x1 of j omega and x2 of t the Fourier transform is x2 of j omega, then a into x1 of t plus b into x2 of t the Fourier transform is a into x1 of j omega plus b into x2 of j omega. This is the uh, linearity property. So let us see. So x of omega equal to minus infinity plus infinity x of t e to the power minus j omega t dt. This is the Fourier transform. Then you can see in place of x of t, we can replace this one. A into x1 of t plus b into x2 of t. Okay. Then a and b are constant, so please take it outside. So into minus infinity plus infinity x1 of this one plus x2 of this one. So this is the Fourier transform of x1 of t. Okay. So a of x1 of j omega plus b into x2 of j omega. So this is the linearity property. Next one is the conjugation property. So if x of t the Fourier transform is x of j omega, x star of t, that is the conjugation, that property is the x star of minus j omega. So let us prove that. So x of j omega, you can see this is the Fourier transform. Okay. So taking conjugate both sides, so x star of j omega, so this is x star of t. So minus, that will be, if we take conjugate, that will be plus. Okay. Now replace omega with minus omega. So you can replace omega with minus omega. So this is the Fourier transform of x star of t. Next is the time reversal. So x of t, the Fourier transform of x of j omega. X of minus t, the Fourier transform of x of minus j omega. Okay. So x of j omega equal to this one. So if we take Fourier transform of this one, so it will be x of minus t. So you can let minus t equal to tau. You can replace minus t with tau. So minus dt equal to d tau. So you can see it will be x of tau e to the minus j omega. T is replaced by tau. So dt equal to minus d tau. Okay. So you can see e to the power minus, this limit you can change. Okay, there's negative values, so that is negative. So there is no negative because we have changed the limits. So x of tau e to the minus j omega minus omega tau. So it is the Fourier transform of x of minus j omega. Okay, so this is the time reversal property. Next is the time scaling property. So x of t, the Fourier transform is x of j omega, x of a t. So it is scaled by the constant a, that is a t. It is 1 by a. So a can be negative or positive. Okay. So this is mode a. Okay. So that can be x j omega a. Okay. That is a is not equal to 0. Okay. So a is positive. For a is positive, that is x star of x means x less of j omega, it will be x of 80. Okay. Now 80 equal to tau. So a into dt equal to d tau. So dt is equal to d tau by a. So we can change the means limit will be same. Okay. So that will be, you can in place of t, it will be that is tau by a. In the dt is d tau by a. Okay. So you can see a by 1 by a kept outside. So it will be x tau e to the minus j omega a into tau. So it is 1 upon a x of j omega by a. Okay. So now it is a is positive, is a is negative, that is negative. Okay. So this is time scaling. Then time shifting property. So it is x of t plus minus t 0. The Fourier transform is x of j omega e to the plus minus j omega t naught. Okay. So now let us take that Fourier transform is x dash of j omega. So x dash j omega is minus into plus infinity. X of t minus t is naught e to the power minus j omega t dt. Let us take t minus t0 equal to tau. So it is t equal to t0 plus tau. So dt equal to d tau. So it will be minus into the limit will not change. Okay. So x tau, that is e to the minus j omega. In place of t, it will be t0 plus tau. So e to the minus j omega t0 will be kept outside. So this one. So this will be x dash j omega. Okay. So this is a time shifting property. Okay. Next is the frequency shifting property. X of t equal to x of j omega. So frequency shifting equal to this one. So it will shifted the frequency. You can see it is omega naught. Okay. So let us prove that. Let e to the j omega 0 t equal to x dash j omega. So this is the x dash of j omega. Okay. So we have taken the plus side. Okay. So that will be x of t e to the power minus j. You can see omega minus omega naught. So that will be x of j omega minus omega naught. Okay. So next differentiation property, x of t, the Fourier transform x of j omega. So dx t by dt, it will be Fourier j omega into x of j omega. So this is the Fourier x of t, inverse Fourier transform. Okay. Now this, if you differentiate this one, it will be this one. This is the inverse Fourier transform. Okay. So it will be 1 upon 2 pi, this x of j omega into this, if you differentiate d by dt of e to the j omega t, it will be e to the j omega t into j omega. So this is the Fourier transform this one. Okay. Now integration in time. So x of t, Fourier transform of x of j omega. So Fourier transform of minus, and that is the infinity t x of deta, it will be 1 upon j omega x of j omega. So xt, we know that this is dt. You can write x of t equal to d by dt of minus infinity to t x of deta. So Fourier transform this one equal to x of t. Now the using the differentiation property, we have seen in the last property. So j omega f Fourier transform this one equal to f of x of t. So this is the f of this, it will be 1 upon j omega x of j omega. So this is the integration in time. Okay. So this is the second part. This is the 8-mark questions. Okay. This is the 8-mark question. So discrete time system described by difference equations. Okay. So we know that these discrete time systems are described by the help of the difference equation. So let us take a recursive system. Okay. So this is z inverse means it is delay. Y of n with delay by 1 unit of time. So it is 1 minus 1. Okay. So let us have a recursive system. That will be y of n equal to x of n. You can see y of n equal to x of n. This is a into y of n minus 1. So it will be y of n equal to x of n plus this one. Okay. A of y of n minus 1. Okay. Next is now let us compute for n is greater than equal to 0. So let us put over here 0. So y of 0 equal to x of 0 plus a into y of minus 1. So y of 1 equal to x of 1. That is a of y 0. So let us put y of 2 also. N value equal to 2. So you can say x of 2 plus y of 1 equal to this one. X of 1 plus a into y of 0. You have put it this one. Similarly, we can put that a of x1 plus, you can put the values. Okay. So x of 2 plus a of y of n. So it will be a into x1 plus a square into x of a square means a square into y of 0. Okay. Now you can put over here x of 2 a of x1, that is y of 0, you can put x of 0 plus a of y of 1 minus 1. Okay. You can put over here, this will be this one. So a 3 y of minus 1 plus a 2 x of 0 plus a into x of 1 plus x of 2. So in general, we can see y of n. So we have computed for, this is y of 2. Okay. So this is our y of 2. So in general, we can write, so you can u of 1. So this 2 means this 2 and 3 means n plus 1 I have written. Okay. Similarly, y of minus 1, this is constant. Okay. So a square means we can write a of n. Okay. Then x of 0, likewise, we can write. Okay. So in summation term, you can see this is the summation term. Okay. So in general term, this one. Okay. So this actually it consists of two parts. This equation consists of two parts. First part you can see. First part is your this one. First part is your contains the term y of minus 1. That is the initial condition of the system. The second part is the response to the x of n. Okay. The first part is here, you can see inside relax, that is n equal to 0. The member should be 0, hence y of minus 1 equal to 0. Okay. The recursive system is relaxed if it is have 0 initial conditions. Okay. So you can see the system is a 0 state, or the corresponding output is called the 0 state response in that condition, n equal to 0. So this is denoted by y of zs. So the 0 state of force response is given by y of z is equal to this one. Okay. For y of minus 1 equal to 0, you can put y of minus, we get this one. Okay. Similarly, for non-relaxed system, okay, you can see y of zi equal to a to the power n plus 1 y of n minus 1. This is called the zero input response or natural response of the system. Okay. So the total response is a y of zs plus y of zi. The zero state response and zero input response. Okay. So the general form, this is the of the LTI system. It is a linear constant coefficient equation. Okay. So this is a 8-mark question. Okay. So these are the references. So thank you for watching this video. If you have any doubt, you can ask me in the comment section. Okay. So thank you all. Have a nice day.